Hello everyone, welcome to another video. In today's video, I will be talking about a container orchestration tool called Docker Swarm. In my last video, I spoke about the concepts of container orchestration with an example, and I also covered the basics of the two most popular container orchestration tools, which is Docker Swarm and Kubernetes. And I also covered the pros and cons of both the tools so that you understand when to use which tool. So if you have not watched that video, I highly recommend that you watch that one to understand the concepts of container orchestration. Anyways, so I'm going to start with the architecture of Docker Swarm. So Docker Swarm follows the principle of client-server architecture, which means that you will have one cluster of servers which are also called nodes. Okay, so as you can see in the diagram, I have 4 servers here. These 4 boxes are 4 servers, also called nodes, and in this you have 3 worker nodes and 1 manager node. Okay, so here what actually happens that when you create a Docker Swarm cluster, you will have at least one master node, or it is also called a manager node, and you will have multiple worker nodes. Okay, it can be one or it can be more than one, but here in this example I have taken 3 worker nodes. So whenever you are deploying an application in a Swarm cluster, what happens? This manager node is the node which give all the instructions in the cluster. For example, which application should be deployed to which node. Okay, so it is decided by this manager node here. Okay, and these nodes just follow the instructions or orders from this master node. Okay, so this is the concept of client server architecture. Okay, so also in a Swarm cluster, how the networking works, again on a very high level I'm talking about. When you are using the Swarm cluster to deploy an application, we use a type of Docker networking. It's called overlay network. Overlay network means that the different nodes in the cluster can talk to each other over this overlay network. Okay, so the meaning of overlay is the networking spans across multiple nodes in the cluster, and that's why one container on any worker node can talk to another container on another worker node. Okay, using this overlay networking only. So that's how the containers are able to talk to each other, and you are able to deploy a full stack application in a Swarm cluster. Okay, so once again I just gave you a very high level overview of it. There are so many things around it, but this is just good enough to get you started with Swarm cluster. Okay, then I'm going to cover some key concepts. Okay, so I'm going to cover some key concepts in Swarm cluster, how the things move actually. So when you are deploying an application, how the workflow is happening and what all resources you create in the cluster. You should know all that so that you are able to deploy the application and understand the concepts that are involved. Okay, so some of the key concepts, or you can say the key resources that you should know before you are actually ready to deploy an application in a Swarm cluster. So Swarm, it is a cluster of Docker nodes, machines managed as a single system. So what actually happens in a Swarm cluster, okay, in a Docker Swarm cluster rather, you will install Docker on each of these nodes, both worker and master nodes. Okay, so when you install that, you will have a Docker daemon installed on this. So whatever containers you deploy, those containers will be managed by that particular Docker daemon that you have installed on each node in the cluster. Okay, so this concept of Swarm means that you have a cluster of nodes, which means you have a group of nodes or machines or servers which are managed as a single system, which is called Swarm. Okay, and this is the command to initiate a Swarm cluster, which we will see when we talk about deploying a 3-tier application in the Swarm cluster. Node, as I just mentioned, that it is a single machine in the Swarm cluster. It can be a manager or a worker. As you can see in the diagram, we have 3 worker nodes and we have 1 manager node, which is also called master node. Okay, and this is the command that you can use to see the number of nodes in the Swarm cluster. Then the concept of manager node, it controls and manages the Swarm, responsible for scheduling and orchestration. Okay, so once again, I just mentioned it when I was talking about this architecture, that you have a manager node which is going to pass orders to all the other worker nodes, and the worker nodes have to follow the orders of the manager node. Okay, so this node is the primary node which manages orchestration of containers on worker nodes. Then worker node executes tasks assigned by managers. So whatever tasks are assigned by the managers are going to be completed by the worker nodes in the cluster. Okay, then all these concepts we'll talk about when I deploy the application. Okay, so don't worry about this part as of now. Just focus on this concept and definition to understand the key terms in the Swarm cluster. Then service, a very important term in Swarm. So service, it is a definition of a task or microservice to run in the Swarm. So what actually happens when you're deploying any container? For example, you have one container which is to be deployed in the Swarm cluster. That container runs as task in a Swarm cluster. Okay, so container is called a task in a Swarm cluster. Remember this. Okay, now the task itself cannot be managed. Okay, the task or the container that we create in a Swarm cluster, it is managed by another object or resource that you create in a Swarm cluster. It's called service. So service is the resource which manages the tasks in the cluster. For example, what image to be used to create a task? Okay, how many replicas of the task should be running in the cluster? Okay, all that is decided by your service resource. So service is a resource which is used to manage the task. Okay, so all the definition or all the configuration of the task is done by a service resource in the Swarm cluster. Okay, then replica. Replica means multiple instances of a service for scaling and high availability. So once again, it is the same thing. So whenever you are creating a task which is a container and you want to scale the task, which means you want to increase the number of instances of a particular task or a container in the cluster, you can use the concept of replica or replication. So this is the command you use. So you just scale your task. Okay, so in this case, if you see Docker service scale web is equal to 5. So web is the name of the service and I'm scaling it to 5 means there will be 5 containers running of this web service, which means that 5 containers will run. So this is the way to scale your service. It's called replicas. Okay, replicas means you are able to scale your task or container for high availability and scalability. Okay, then another important term is stack. Stack is a collection of services defined using a Docker compose.yml file. So what basically stack means, if we are deploying a 3-tier application, which means that we have 3 layers, right, of our application. We have a front end, we have a back end, and we have a database, just as an example. So your one application, okay, your one full application is consisting of 3 different containers, right? So stack means the entire layers of application that you deploy to deploy one single application. Okay, so stack, the meaning of stack is you are able to deploy a full-fledged application as a single application using the concept of stack. Okay, I hope you understood. if not, let me repeat. So if you're deploying a 3-tier application, so you have 3 types of containers: front end, back end, and database. So your one application contains 3 different containers, right? So this one application is deployed as a stack in the Swarm cluster. Okay, it's called stack. Okay, once again, I'm going to do a hands-on demo so that you understand what these terms actually mean when we actually deploy it inside the cluster. Okay, and this is the command to deploy a stack application, and it uses docker compose.yml file. So if you've watched my earlier videos, I've already covered what is docker compose. Okay, so stack also uses docker compose.yml file to deploy, but the application is deployed slightly differently, because when you're using docker compose, you can only deploy to one host, right? One Docker host. But in a Swarm cluster, we have to deploy a service to multiple nodes or multiple servers. So that's why we use stack to deploy the application and not docker compose. Okay, docker compose can be used when you have one Docker host. Okay, then overlay network. Overlay network, as I just explained, that it is the virtual network that spans all nodes in the Swarm cluster, enabling inter-service communication, which means that if one container, for example, we are deploying a 3-tier application, the front end is deployed to worker 1, the back end is on worker 2, and database is on worker 3. So how your application will be able to talk to each other, that will happen via this networking solution called overlay networking. Okay, then why to use Docker Swarm? So it is easy to set up as compared to Kubernetes, which takes slightly more effort and time to be deployed or to be configured. It is built into Docker CLI. So when you install Docker tool, you get Docker Swarm installed as well, but it is not initialized. You have to initialize the Swarm cluster. Okay, so no extra installations are needed, but you still need the initialization of your Swarm cluster, which I'm going to show you. Then it is great for small to medium production environments. Okay, so as I mentioned, Docker Swarm performs basic orchestration, but it does not have a lot of features that Kubernetes has. So it is only suitable for small and medium production environments and not some really complex and some big applications, right? So for that you will use Kubernetes mostly. Okay, then it is secure by default. It uses mutual TLS encryption, which means that whatever communication happens between the different nodes in the cluster, it is secured by default. It uses TLS, mutual TLS. Okay, then you are able to auto load balance between replicas. So when you scale the application, then you are able to auto load balance the traffic to these different replicas. Okay, I hope the concept of Docker Swarm theoretically it is clear to you. If you still have doubts, you can always reach out to me in the comment section. Okay, next we will be deploying the sample 3-tier application with Docker Swarm and see how a full-fledged application is deployed in the Swarm cluster. So to deploy a sample 3-tier application in Docker Swarm, I have given you step-by-step instructions that you can follow and understand how an application is deployed, and you will also be able to see the resources that we spoke about in the key concept section here. Okay, so I'm taking one master node, or we can also call it a manager node, and one worker node for this deployment. The workers can also be called as slave nodes. Okay, as you can see in the diagram, so instead of 3, I'm taking one worker node and one manager node. Okay, and we'll be using overlay networking to deploy the application from manager to the worker node. So all the administrative tasks, or you can say the command execution tasks, will be happening on our manager node, and the resources or the tasks which are called, the containers which are called tasks in a Swarm cluster will be deployed on our worker node. Okay, so we have to see step by step how to initialize the cluster and how we can use it to deploy our application. Okay, so step number 1 is you need to provision 2 AWS EC2 instances, preferably with AMI based out of Ubuntu 24.04 LTS. So you can take any AMI of your choice, but I'm taking the one that is more common when you do these type of deployments. Okay, but it still depends from company to company, from project to project. But I have seen Ubuntu being used by a lot of development teams to do their development work, and for any local testing or local development also they use AMI based out of Ubuntu, and I'm trying to use the latest version, which is 24.04 LTS. Okay, so this is my AWS account and I've already provisioned these 2 instances. If you need any help related to creation of EC2 instances, you can watch any of my previous videos in the AWS for DevOps series playlist. You can see there's one video on EC2 instances specifically, so there I've covered all that. Okay, so I have 2 EC2 instances ready with me, and these 2 instances will be part of the Swarm cluster that I'm going to initialize. Then on both EC2 instances we need to install Docker. As I mentioned earlier, that whatever node or server you want to add to your Swarm cluster, you need to install you need to install Docker on those servers or nodes. So to do that, you can follow the instructions given here. Okay, so let's do that. So I'll open it in a new tab. So this is the official documentation from Docker to install Docker on Ubuntu. So it's pretty straightforward. Okay, the first command is to uninstall old version. So this is the command. Okay, and also I have already SSH to both the machines. So I have one manager machine and this is my worker machine here. Okay, so let's start to deploy, or let's start the process of deploying the 3-tier application in the Swarm cluster. But first we have to install Docker on both the nodes. So I'll copy this, come here, and here on both machines we have to install Docker. So run the same command on both the machines. Next command is this one. I'm going to use the Docker's apt repository. So just copy and paste the entire command. Okay, it's pretty straightforward. As I mentioned, just 3 commands you need to get started with installation and configuration of Docker on Ubuntu machine. That's it. Okay, this is done. And this command is going to install all the tools that you need to start using Docker on any machine based out of Ubuntu. Okay, this is done. And then if you want to test the installation, you can just run this to test it. It's not a mandatory step, but it's optional, but it's like just to confirm the installation that you have installed and configured Docker correctly. Okay, so and when you see this message shows that your installation appears to be working correctly. So Docker has successfully been installed and configured on your machine. Okay, similarly on this machine also. Oh, sorry, I'll just copy the command again, this one. It's going to create a type of a demo container named hello world, and it's going to confirm the installation that is working properly on your machine. Okay, so once again you see this message. So Docker has successfully been installed on your 2 machines. Fine. Next, let's see the instructions then. So after you have installed Docker on both the nodes, on the master node initiate the Swarm cluster. So if you see, I did not install Docker Swarm. Okay, I just installed Docker, but Docker Swarm is also installed by default, but it is not initialized. Okay, so on the master node you have to initialize the Swarm cluster. To do that, you can copy this command, and this is my manager node or the master node. I'll just run this command to initialize the Swarm cluster. So this is how you will see Swarm initialized current node. This is a node ID that it has generated is now a manager. So whatever node you have in your Swarm cluster, it will have either a manager role or a worker role. Okay, I'll show you also how it looks like, how to check that. So but just understand, when you initialize the cluster on any node, that node will become the manager. Okay, so I'm using this node as manager node, and if you want to add another node to the cluster as a worker node, so it is given here to add a worker to this Swarm, run the following command. So this is the command that you need to run on any machine that you want to add to your Swarm cluster as worker node. Okay, so this is the joining token that is generated automatically. You just have to copy and paste this command like this. Go to your worker node which you want to add to the Swarm cluster. Okay, since I'm using Ubuntu here, so I'll be using sudo, and just copy and paste the command as it is, and you will see this message: this node joined a Swarm as a worker. Okay, so now if you want to check the status of your cluster, you can do docker node ls command. Node ls means you are trying to list out the nodes in your Swarm cluster. Okay, since I'm being logged in as Ubuntu and I haven't added Ubuntu to the Docker user group, so I'll be using sudo with all these commands. So now you can see I have two nodes. Once this host name is manager already, and it is the leader. Okay, which means that it is the master node or the manager node, and other node is the worker node. As you don't see any manager status, okay, it is blank, which means that it is a worker node. Okay, and both nodes are in ready status. Okay, and you can see the IP. So this is the same IP of the machine that I just added to the Swarm cluster, which so this machine has been added to my Swarm cluster as worker node. Okay, I hope this is clear to you till now. It's pretty straightforward. It's pretty simple to set it up. Okay, as compared to Kubernetes, yes, Docker Swarm is pretty easy to initialize and configure, as we are seeing now. Okay, so we have a Swarm cluster ready with us. One is the worker node, and other one is the master node. Okay, next is on the worker node, it's saying just run this Docker Swarm join command using this, which we've already done. So this step is already done, and this also we have just done it. We have just checked the status of our Swarm cluster. It's fine. Now you should have a Git installed, because the project that we'll be deploying, the 3-tier project, it's in a GitHub repository. So you need to clone the repository to the machine, to this master machine, or you can say to the manager node, where you will be using it to deploy the application. So you should have this Git installed. So I'll just copy this one, and I'll go to my master machine, the manager machine, and I'll just install this. So Git is already installed. That's good. Next is deploy a Swarm stack for the cloned project. Okay, so now I'll just clone this repo. So you just have to copy and paste this command as it is, and it's going to clone the repository to your manager node. It's cloned. Now let's go inside this. So this is the 3-tier project that I was talking about. Okay, so you have docker compose.yml file. As I mentioned, in a Swarm cluster, we use docker compose.yml file to deploy our application as a stack. Okay, and one more thing, you can deploy the application containers or tasks on your manager node also and your worker node also. But ideally, or you can say in terms of best practices, it is always better to deploy your containers on worker nodes and keep manager node as just for managing the activities in the cluster, and do not run any task on it. But you do have the option to deploy the task on manager node also. Okay, now we have a front end here, we have a back end, and we have one database as well. Okay, so let's just understand the architecture of the application that we are going to deploy on a very high level. So what it's going to be, so there are just 3 tiers to this application. Okay, so we have one database layer. Okay, database layer is there. We have one backend, and we have a front end. Okay, and they all can talk to each other on the same network that we'll be defining in our docker compose.yml file. Okay, and for front end and back end, I'm using a docker file. Okay, I'm using a docker file to create the image, to create the custom image. For database, I'm using an image that is already there on Docker Hub, okay, which is going to be Postgres. So, okay, so this is the architecture that we want to deploy inside a Swarm cluster. Okay, so it's going to be a 3-tier application: front end, back end, and database. Front end and back end will have one custom image each that we'll be creating on our own, and for database we'll be using an image that is already available on Docker Hub. Okay, I hope this is clear. Okay, and that's all you need to know as of now to deploy the application. Okay, I don't want to go too deep into the application here, because my focus of this video is to show you how you can deploy an application as a DevOps engineer or a site reliability engineer in a Swarm cluster. Okay, so let's go back here, and as you can see, if you do ll on B, which is for backend, you can see I have a Docker file and I have another file, server.js, that will be used inside my Docker file to create the component. Okay, then if I do ll on FE, you can see the same thing. You have Docker file, you have index.html, which is for the front end. Okay, and I have another folder called assets, which is going to ensure that I have a front end which actually looks like a real website, a real world website. Okay, that I'm going to show you in a moment. All right, and since I'm using the database image which is already available on Docker Hub, I don't need to have any Docker file to create a new image. Okay, so that's why you don't see any folder for database. So if I just show you the docker compose.yml file as well, so this is the image that I'll be using for my application, and the port on which the front end will be exposed is port 80 on the Docker host, which is mapped to inside of the container on port 80 as well. Okay, so we can access our application on the IP address of the node on which the task will be running, and we can just add port 80 to it to access the application from the front end. Then if you see this networks, I'm using webnet. Okay, and what I'm trying to achieve here is I want to have the same network for all the 3 containers, which means that these 3 containers will be connected via the same network. It's going to be a custom network that I'll be creating. It will be called webnet. Then I'm also specifying where I want to deploy this container. Okay, so I want to deploy this container on worker node. So as you can see, deploy placement constraint. So this is the way you specify where you want to deploy. I want to deploy this to any node in the cluster that has its role set as worker. So this is how you define that. I don't want to deploy the application on manager node, I want to deploy it on a worker node. So I'm specifying here. Okay, the node role should be worker. Similar for this also, and for these two I'm specifying. And if I just scroll a little bit down Here also you can see, and for database also I'm specifying the node role as worker, and then I'm specifying the network, which is going to be webnet. So here I'm trying to create the network here using the Docker Compose file. It's going to be webnet, and this network will be attached to all the containers in my application. And then for database, I'm using this volume called db data. Okay, so I'm going to create this volume, and then I'm going to mount it inside the container for my database container, as you can see here. And then I'm specifying the image name. So this image is already available on Docker Hub. And then since this database needs some environment variables as well, so I'm passing in those here. Okay, like this key value format. But yes, in real world, you won't see this sensitive information of password like this. Okay, and in real world scenarios, you will be using a secrets manager. Either you can use in AWS, you have AWS secrets manager to pass the values from there to here, or you can use another tool called HashiCorp Vault, for example, which is a very popular tool to keep your secrets. So in that way, we'll be passing the values in real world. But for this application, but for this video, I want to keep things simple. Okay, so I'm using the this hard-coded value of the password. Okay, I hope this file is clear to you. It's pretty straightforward. There's not much to it, as you can see. Okay, so let's come out of it and let's see the steps given on the GitHub repo. Okay, so cd into Swarm app, which I've already done. Then the next is to deploy the stack straight away using this command. Okay, one more thing I want to mention here is I've given you these two folders, BE and FE, to build your images, okay, for a backend and front end. But I have already built these images and put it on Docker Hub. Okay, so if you see my Docker file, this Docker compose.yml file again, I'm already specifying some names here. Okay, as you can see, I'm specifying the name as bhavuk_m/fe-swarm. So what I did actually before this video, I built the image myself, and I have already pushed these images to my Docker Hub. So these images are still available. Okay, so as you can see, these are my custom images. I'm using my own Docker Hub username and some custom name. Similarly for backend as well, I'm using this name. So these images are already available on Docker Hub. If you want to use these images as it is, you can use this. It's going to work. You do not need to build the images. But if you want to just understand, or if you want to build the images on your own, you can do so using these two Docker files for backend and front end. Okay, as I just showed you that these have two Docker files, I mean one each for backend and front end. So you can use a Docker build command and build your image and then push it to Docker Hub using your own Docker Hub username, and then use those images in your Docker compose.yml file. Okay, so it's up to you. To make it easier for you, I have already built the images and I've pushed it to Docker Hub so that you can use it in the Docker compose.yml file as it is. Whatever names are given, it's so these are the valid names that you can use. Okay, so for this video, since the images are already built, I'm not going to build it again. If you need any help, you can refer to my other videos on Docker for DevOps series, where I've showed you how to build an image from Docker file. Okay, if you need any help, or I've also covered how to tag the images and how to push these to your Docker Hub using your Docker Hub username and password. Okay, so to save time on this video, I'm going to straight away use this Docker compose.yml file with the names of the images already given in the file itself. Okay, I hope this is clear to you. If you still have any doubts, please reach out to me in the comment section. Alright, so what I'm going to do is, this is the command that you can use to deploy your application as a Swarm stack in a Swarm cluster. Okay, I'll just explain it. I'm using sudo here because I'm still logged in as Ubuntu, a sudo user, and I have not added Ubuntu to the Docker user group. Okay, so I have to use sudo with all the commands, else I'm going to get a permission error. Okay, so I'm using sudo docker stack deploy. So this is the command to deploy a full-fledged multi-tier application in a Swarm cluster. Docker stack deploy command. Okay, so you do a docker stack deploy -c to specify your compose file. Okay, so here you have to specify the absolute path to the docker compose.yml file. So since I'm already inside this swarm app folder where I have this docker compose.yml file, I'm just specifying the name of the file. I'm not specifying the absolute path. But if you have this file located somewhere else on the machine, then you have to specify the absolute path here, else this command is going to fail. Then I'm specifying the name of the stack. Okay, so this can be any name of your choice. I'm using swarm app, but you can use any name here. It is just a name that you give to your swarm stack after deployment. Okay, so in docker compose.yml file, we have our configuration for backend, frontend, and database already. Okay, so it's going to use that docker compose.yml file as the declarative configuration to create a 3-tier application. Okay, so all the configuration is inside a docker compose.yml file. It is just that we are deploying it as a stack in a swarm cluster. So just execute it, and you will see this message. You can ignore this one. Okay, it's not, I mean, you can just ignore this message. You just have to see if you are able to create the containers. As you can see, it created the network as webnet. It also created a service called swarm app _ db. It also created a service swarm app _ frontend, and one for backend as well. So if you see here, I deployed the stack, but it created these 3 services. So as I mentioned, in a swarm cluster, you don't create the containers directly. You need another resource or object which is called service. So service is the resource that you create in swarm cluster to manage your Docker containers, which are called tasks in a swarm cluster. Okay, so now let's see the next command. So after you have deployed the application, you can just see if you are able to access the application or not. So as I mentioned, all the containers are going to be deployed on the worker node, and since I only have one worker node in the cluster, I should be able to access my application on the worker node's IP address and port 80, which I'm using as the port mapping inside my docker compose.yml file for the front end part. Okay, if you remember. So just click on this worker node here and just copy the public IP, and let's open it in an incognito window, paste, and I don't have to specify port 80 because by default it is port 80. It's a insecure site, that's fine, and you can see we are able to access the application. So this is my container application running inside a swarm cluster, and you can see it looks like a real world website only, right? So this is how the applications are deployed in a swarm cluster. Okay, I mean in a most basic way, but yes, I mean there are so many things, there are so many components that goes into when you're deploying it in a production environment, but the concepts or the fundamentals are going to be remain the same. Okay, so we are able to access our application. This is fine. Let's go to the steps again here. So we are able to access the application. Now we can see the status of our services that we have deployed. So you can copy this command, go to your worker node and run this command. So this is going to show you the status of all the services running. So this is a service ID, and this is the name of the service that is running, and mode is replicated, and we have 1 replicas. Okay, so if you don't specify any replica count or scaling count for your containers, then it's going to be 1 container only. So as you can see, 1 out of 1 is running for each of the 3 services. Okay, and this is the name of the image. As I mentioned, the image is already available on Docker Hub, so you can use it as it is. Okay, so all the 3 images are available on Docker Hub, so we did not need to build the image. And the backend is running on port 3000, the front end is running on port 80. Okay, and here is our database, which is using this Postgres version 15 image. Okay, so this is the way to check the status of the services which is running your tasks. Okay, the tasks are called containers, but you cannot manage tasks individually in a swarm cluster. You need service resource to manage those. Okay, next, on the worker node, So since the containers are deployed on our worker node, by logging on to the worker node, you can also check the status of the containers running. Okay, so for that you can use a traditional Docker command, that is Docker ps command. So I'll go here on the worker node and I'll try to see the containers if it's running or not. And you can see we have 3 containers running now. Okay, so we are using this standard Docker ps command because the Docker swarm commands are not going to work on the worker node. Those are only for the node which have leader role, or we can say which are manager in the cluster. Only those nodes can actually use the swarm commands, but the worker node can still use the standard or the conventional Docker commands to check the status of the containers running on them. As you can see here, so these 3 containers are running on my worker node here. Okay, next, now let's just try to scale the application manually. Okay, so by default in a swarm cluster you cannot automatically scale the application. Okay, because Docker swarm does not come up with any tooling that is available to automatically scale your application. This is the default I'm talking about, but you have a lot of different third-party tools on scripts that you can use to enable automatic scaling in your swarm cluster for a particular container, but it's going to take some time and effort, and it's going to be really complex to manage, especially if you're using it in a big complex environment for a complex application. In that case, it's going to be a lot of headache, and this is the reason people want to use Kubernetes for complex applications. Okay, but you can still scale the application manually. So this is the command. Let's try to execute it on the master node. So I'll just clear the screen, and what I'm trying to do here is I'm using this Docker service scale command, and then I'm specifying the name of the container that I want to scale. So as we know that each container has one replica only, which means that just one task of each container is running at the moment, and I want to scale the front end to 3. Okay, so let's just run this command, and you can see it's going to run 2 more containers to it. Now if I run the same command again, Docker service ls, you will see the front end now has 3 containers running, or 3 tasks running in the cluster. Okay, so after scaling the application, I'm able to see 3 tasks running in the cluster. I hope this is clear to you. So now we can check the status of the replicated service. We have already done that. Next is another command is sudo docker service ps, then the name of the service. Let's run this command. So now you can see that this is going to show you the status of the service itself. So if you want to see the status of the tasks, so these are the task IDs. Okay, so we have 3 tasks running as part of this service. Name of the service is swarm app underscore frontend, and this service has 3 tasks running now. Okay, task 1, task 2, task 3, and this is the image it is using. And on which node these tasks are running, you can check it via this command only. So it is showing clearly that these tasks are running on this node, which is our worker node here. As you can see, the name, it has the same host name as our worker node, and status is running, which is the desired state, and it has been running since 6 minutes. Okay, this container has been running since 6 minutes, but after we scaled it like 1 minute ago, we have 2 more containers running. Okay, I hope this is clear to you. It's pretty straightforward. Okay, okay, next is on the master node. Let's run this command. I'll just explain you the reason I'm doing it. So what this command is going to show you is the live status. I'm using watch here at the start of the command, which is going to show me the live status of my services. Okay, so this is a live status, which means that if any container or any task fails, this is going to update itself every 2 seconds. If you see here, every 2 seconds this output is going to update itself. So if I delete any container, for example, okay, so you can see it here on this screen. Okay, how? So what I'm trying to show you here is that if you delete any container after you have scaled that, it's going to automatically get the containers up and running. Okay, but as you can see, I don't have any mechanism by which I can specify, like, whenever average CPU utilization goes over 80%, 2 more containers should be added to the cluster. So that type of automatic configuration is not available. But once you have scaled the application, if any container crashes or deletes, in that case it's going to automatically restore that container. Okay, so since I manually scaled the application using this manual command, now let's run this sudo docker ps on the worker node to see the current status of the containers. So now we have, instead of 3, we have 5 containers. Okay, 3 for the front end and 1 each for backend and database. Okay, now what I'll try to do is I'll try to delete the container, one container manually. So this is the container, this is the command I can use. So this command should be run on your worker node. Okay, on the worker node I will be manually deleting one container. So I'm using sudo docker rm-f, which means that I want to remove this container forcefully, and I can specify the container ID here. It's going to be this one. So let's remove this container. Okay, once I do that, you can see the status will be updated here instantly. Deleted, and you can see the containers are 2 out of 3 now, but in a moment it's going to change to 3 automatically. As you can see now, it has changed to 3 by 3. So this is how the scaling works by default in a Swarm cluster. You can scale the application manually, but you don't have any mechanism by which it can scale out and scale in the number of tasks for a particular container automatically based on some criteria or some threshold, some metric. Okay, so that option is not available by default, but you can use some third-party tools or scripts to enable that as well in a Swarm cluster. Okay, but as I mentioned, as the application's architecture becomes complex, it gets really difficult for you to manage this type of setup. Okay, but for small setups and for medium scale setups, it is still good enough. Okay, so it depends what your project needs, what is your exact use case, and you can use either Docker Swarm or Kubernetes depending on that. Okay, so as you can see, the application after scaling, it has automatically restored or created the new container for us. Okay, so if I do sudo docker ps again, you can see containers are 5 containers. Okay, and this new container is just up about a minute ago. Okay, I hope the concept of scaling is clear to you in a Swarm cluster. Alright, this is done. So that's all I wanted to cover in this video. I hope you liked it. If you did, please hit the like button. Please subscribe to my channel to keep me motivated to create more content like this, and do share this video with your friends and colleagues. Also, if you have any feedback, anything you want to share related to the content that I create, please reach out to me in the comment section. Alright guys, that's all for this one, and I'm going to see you in the next one. Bye for now.